Hello students, welcome to physics class. In this class we are going to discuss about the magnetic force. Actually this part is already I started in a last class only. The same part I will continue today, and next one more concept we are going to understand in this class, that is the direction of the magnetic force. And along with this, can we define the magnetic field strength with the help of magnetic force? We can define the magnetic field strength with help of this magnetic force. And finally we are going to discuss about the SI unit of the magnetic field strength, that is a B. Magnetic field. These three topics we are going to cover in this class. See, yesterday I said moving charge particles always produces the magnetic field. Fine. These moving charge particles, when they enter into the magnetic field, sometimes they experience the force. That force is called as magnetic force. The already formula also given yesterday. F is equal to Q into V cross B. F is equal to Q into V cross B. This is the magnetic force formula. How we got this magnetic force? When the charged particle enter into the magnetic field, it experiences the force. That force is nothing but the magnetic force. That symbol is F. Q V cross B. What is the V? Velocity of the charged particle. B is the magnetic field strength, means in which magnetic field that moving charge particle entering, that magnetic field strength it is, whether it is strong magnetic field or weak magnetic field, like that. It is strength of that magnetic field, in which magnetic field the charged particle moving or entering. Okay. Q is the charge of the moving charge particle. Already I have given a formula for this one. One more, I simplified this formula also. Q is equal to VB sin theta. How I wrote this one, this step? We know that vector A cross vector B is equal to AB sin theta. It is the cross product of two vectors. With help of this formula, I wrote this one. See, V is a vector, velocity vector it is. B is a magnetic field strength, that is also vector. Or generally it is a magnetic field B. V cross B is nothing but the VB sin theta. That's why I written this one. Here F is maximum. Yesterday I wrote this one. F is maximum. F is maximum when F is maximum if theta is equal to 90 degree. Remember, this F value becomes a maximum value when theta is equal to 90 degree. What happens if theta equal to 90 degree? If I consider theta is equal to 90 degree, sin 90 degree is equal to 1. Therefore, F becomes a QVB into 1. If QVB into 1 means UVB. This is the maximum value of F. If F is minimum, when it is minimum? Yesterday I explained this one. F is minimum if theta is equal to 0. If theta is equal to 0, think it. If theta is equal to 0, what happens in this equation? F is equal to QVB sin 0. What is the sin 0 value? Sin 0 value is 0. Already we studied in first year. Sin 0 is 0, sin 90 is 1. So therefore sin 0 means 0. QVB into 0 means 0. This is the F. Remember, F 0 means there is no force at all. F is equal to maximum when it is theta is equal to 90 degree, that's fine. F is minimum when it is theta is equal to 0. F is minimum when theta is equal to 0. If theta is equal to 0, sin 0. Sin 0 means 0. Therefore, Q will be into sin 0. QVB into sin 0 means QVB 0, total 0. Therefore F value becomes 0. If F value is 0 means there is no force, there is no existence of force. There is no force acting on that charged particle. When theta is equal to 0, what is the theta? Which theta it is? Theta is the angle between the velocity vector and the magnetic field direction. Remember, it is the angle between the velocity and magnetic field. The angle between these two terms, velocity and magnetic field, the angle between these two is theta value. If the angle between these two is 0 degree, then force is minimum, that is 0. Force is maximum when the angle between V and B is 90 degree. When angle between the velocity V and B is 90 degree, remember once again, angle between the V and B is 90 degree, then force is maximum. If angle between the V and B is 0 degree, then force is minimum, or there is no force at all. Minimum means 0 force it is. For more clear the concept, I'll explain how it is. Yesterday I had drawn the one diagram. I have shown the magnetic field like this. Which magnetic field is in which direction it is? It is coming out from the board. Fine, it is coming out from the board in this direction. The magnetic field is in this direction, means it is coming out from the board. Okay, here positive charge is there. If I send the charged particle with a velocity v, velocity is a vector quantity, as we know already. Velocity is vector quantity. If the charged particle, if I send in this direction, magnetic field in this direction, here out of the board, if I send the charged particle in this way, means this one and this direction, both are 90 degree, both are perpendicular, then force is maximum. Because angle between the B means magnetic field. B is nothing but the magnetic field. Magnetic field is this direction. Your velocity vector, that is a charged particle coming in this direction. Magnetic field here, velocity means charged particle is in this direction. Both angle between these two is 90 degree. Therefore maximum force. Therefore when it enters into the magnetic field, it start to take the when it enters, it start to rotate in a circular form. Instead of moving straight line, initially it is coming in a straight line only, but when it enters this magnetic field, because angle between the magnetic field and the velocity vector is 90 degree, therefore maximum force it experiences. Therefore it start to move in a circular path instead of straight line path. Actually ಯಾವ ತರ ಹೋಗಬೇಕಾಗಿತ್ತು, it must travel in a straight line, but because of this magnetic field, it start to take the circular path like this. Fine, this is the explanation. Okay, instead of sending this charged particle in this way, if I send the one more time, think it, charged particle, if the velocity is coming, magnetic field is coming out of the board. Magnetic field, how it is? Magnetic field is coming out of the board in this way. If I send the charged particle in opposite way, what happens? Or magnetic field is moving in this way, magnetic field direction is here in this direction, charged particle also here. If the charged particle velocity and the magnetic field direction both are same, parallel or same direction, the magnetic field also in this direction, velocity also in this direction, then what is the angle between these two? 0. ಎರಡು ಸೇಮ್ magnetic field ಯಾವ ಡೈರೆಕ್ಷನ್ ಹೋಗ್ತದೆ, in the same direction if you send the charged particle, then the angle between these two, velocity vector and magnetic field, is 0. Therefore force is minimum. That is a 0 force. This much you remember. If the charged particle moving in a perpendicular to the magnetic field, force is maximum. If the charged particle moving along the magnetic field, moving along the uniform magnetic field, it experiences the zero force, or it does not experience the force. Zero force means it does not experience the force. Therefore, it will move in a straight line instead of taking the circular path. When it is moving in a perpendicular direction to the magnetic field, it takes a circular path because it experiences the force. When the charged particle moving along the uniform field, then it experiences the zero force. Therefore, there is no force at all. Therefore, the charged particle move in a straight line. Okay, if it is in a perpendicular direction, it will take the circular path. If along the direction of the magnetic field, or then it will move in a straight line path. So, if the in between state, just note down some points here. If charged particle moving perpendicular, this is symbol of perpendicular to the charged particle moving perpendicular to the moving in the direction perpendicular to the magnetic field. Then charged particle takes circular path. Remember, when it is, if the moving charged particle and magnetic field both are perpendicular, then it takes the circular path. First point. Second one, if charged particle moving along the uniform magnetic field or uniform magnetic field, moving along the uniform magnetic field, then charged particle move in straight line path. Because f is 0. Bracket. If the charged particle moving along the magnetic field, then the angle between the velocity and magnetic field direction angle is 0. Therefore, f is 0. If f is 0 means there is no force. If there is no force, it will move straight line. And one more question. Instead of 90 degree, here perpendicular means it is the angle between the velocity and v and b in this formula, v and b. Okay, the angle between a and b is 90 degree, then f is maximum. If angle between the v and b is 0 degree, f is minimum. If in between the 90 degree and 0 degree, what happens? If 0 degree minimum force, 90 degree maximum force. If in between 0 and 90 degree, what is the force and what is the path of the charged particle? Means if along the magnetic field, if you send the charged particle, there is no force. If you send the charged particle perpendicular to the magnetic field, it experiences force, it takes a circular path. But next question arises, instead of 0 degree or 90 degree, we are sending the charged particle in between the angle. Means how? It is not along the magnetic field, it is not perpendicular to the magnetic field. ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಹಿಂಗೆ ಬರ್ತಿತ್ತಂದ್ರೆ ಅದ್ರ ಗುಂಟನೂ ಕಳ್ಸಂಗಿಲ್ಲ ನಾನು, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಜೊತೆಗೂ ಕಳ್ಸೋದಿಲ್ಲ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ಗೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಡ್ಯಾಶ್ ಹಿಂಗೂ ಕಳ್ಸಂಗಿಲ್ಲ. once it makes some angle instead of 0 degree and 90 degree, if it makes a 45 degree, if it makes a 30 degree, what happens? That question is. If the charged particle, the path of charged particle moving, the path of the charged particle moving in uniform magnetic field uniform magnetic field with the initial velocity with initial velocity at an angle between 0 degree and 90 degree is helical path. Helical in nature. Very interesting it is. See, if angle between the V and B is 0 degree, then no force, zero force. If angle between the V and B is 90 degree, maximum force. How much it is? QVB. Maximum force is QVB. If theta is equal to 0, F is equal to 0. If theta is equal to 90 degree, F is equal to maximum, that is a QVB. If theta is equal to in between, if theta is in between, theta value is greater than 0 degree and less than 90 degree, then F is theta is 0 degree, in between 0 degree and 90 degree, then F is then helical path. Means if theta equal 0, F is 0 and straight line path. Circular path. See, if theta equal to 0, F is 0 and straight line path. The charged particle, if angle between the B and B is 0, then force is 0, therefore it will move in a straight line. If the theta is 90 degree, F is equal to QVB, it will take the circular path. If theta is in between 0 and 90 degree, then F is not a fixed value, it depends upon theta. It depends upon theta, which path it will. But which type of path it will take? Helical path. What is the helical path? How it is? It will take like this. This type. Straight line path means straight line. Circular path means you can understand. But helical path means in this way. In this way it will move, helical path. See how it is, very interestingly. If theta is equal to 0, force is 0, so it will move straight line. If theta equal to 90 degree, F is QVB, circular path. If theta is in between 90 and theta 0 degree, if theta is in between 90 and 0, then it will take the helical path. Then what is the F value? F value is not fixed, it depends upon theta value. Whether you are taking theta value 30 degree, whether you are taking the theta value 45 degree, whether it is 60 degree, your choice. Which theta you will take, and depend upon that it will, its value going to change. The F value is going to change with the theta value, but the path is always in this form. This is called helical path. This is called helical path. Okay, next we must know that what is the direction of this magnetic force. How can we define the magnetic force direction? To define this magnetic force direction, we use the left hand Fleming's rule, Fleming's left hand rule. Fleming's left hand rule. Direction of the, see, take your left hand, keep your forefinger, mid finger and thumb perpendicular to each other in this form. In this form, you just hold it like this. Okay. If this forefinger indicates magnetic field, then your mid finger indicates velocity, then thumb indicates the force. See, Fleming's left hand rule, LHR. In shortcut I wrote. This is thumb, forefinger, finger, and this is a mid finger. I hold like this. This forefinger indicates the magnetic field, that is a B. Magnetic field B, and thumb indicates the force F. This is a vector. Then mid finger indicates the velocity. Remember, this force, magnetic force, whatever I wrote here, formula F is equal to QV cross B. This is the magnetic force. This force is always perpendicular to the plane containing V and B. Where is B? Here. Where is B? Here. To both these V and B, for these two, the force is perpendicular. Remember, the force direction, force is always perpendicular to the plane containing V and B. Velocity ಮತ್ತು B ಗೆ perpendicular ಆಗಿ force ಇರುತ್ತೆ ಯಾವಾಗಲೂ ಕೂಡ. Remember this one. The force is always perpendicular to the plane containing B and V. In which plane both V and B will lies, to that plane the force is perpendicular. ಯಾವ ಪ್ಲೇನಲ್ಲಿ V ಮತ್ತು B ಇರ್ತದೆ, ವೆಲಾಸಿಟಿ ಮತ್ತು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇರ್ತದೆ, ಅದಕ್ಕೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿ ಫೋರ್ಸ್ ಇರ್ತದೆ. The force is always perpendicular to the plane containing B and V. V ಮತ್ತು B ಎರಡಕ್ಕೂ ಕೂಡ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಫೋರ್ಸ್ ಇರ್ತದೆ. That's why to explain this one I use the Fleming's left hand rule. In Fleming's left hand rule, the forefinger indicates magnetic field, the force indicates by the thumb, and velocity indicates by your mid finger. Usually, to understand or to remember purpose, we can say like that. F means father, magnetic field M, mother, this is child. Father, mother, child. You can remember for remembering purpose, not necessary to follow this one only. Don't write the father, mother, child like that in your examination. Just you write the in examination. F is a thumb, magnetic field indicates that the indicates by the forefinger and the velocity indicated by the mid finger. For these two, the plane containing V and B, this is the plane. For this plane, thus F is perpendicular. Always, what is the direction of the F? F is perpendicular to the, note down, note point. F is perpendicular to plane containing V and B. V and B. The F is perpendicular to the plane containing V and B. This point you should remember always. This is about the direction of the magnetic force. How to understand the magnetic? Already I said the magnetic field direction. For understand the magnetic field direction, I use the thumb rule. The current indicated by the thumb and the curved finger indicates the magnetic field. But now I am explaining about the magnetic force. Magnetic force direction is given by the Fleming's left hand rule. In left hand rule, the forefinger indicates the magnetic field, middle finger indicates the velocity, and thumb indicates the force. Don't get confused. And if you have any doubts regarding this one, you can ask through the. And one more thing, I want to express this one. Yesterday I have given one question, asked a question, but except Kaveri, no one student is tried to attempt that one. I asked in previous lecture. I thought that most of you are not watching the videos properly. Try to answer each and every question, whatever I asked in this video classes, through your SMS. Only Kaveri Bangi has given a correct answer, and one more day I am giving to you to solve that answer, to solve that question. Okay, thank you.